So finally, our final video for today, we're going to go over chapter 23, 24, and 15. We're looking at our cake, pastry, and gelatin. So after this chapter, you'll be able to identify the various types of cakes. We're going to look at the different ingredients and preparation techniques of shortened and foam cakes, looking at the principles of basic pastry preparation, and we're going to look at what gelatin is. After all this, we're going to look at the preparation techniques of gelatin based products. All right. So when we're looking at our cakes, they're going to be defined by their fat content. All right. So look at our shortened cake. Our shortened cake is made with fat, meaning this is referring back to the gluten production. Shortening our fat, the fat actually coats the gluten and the gliadin. So we do get something that's a little bit more tender because we made it with fat. Whereas our unshortened cakes, all right, they're tender because we add a foam to them or a sponge. All right. So these are made without fat, but we still get that aeration. We get that nice, delicate, tender, the tender texture from it. And when we're looking at our chiffon cakes, it's a combination of our shortened and unshortened cakes. We will get into that. So our shortened cakes, this is a good slide to study from. Our shortened cakes, again, these are made with fat, but they are leavened with our baking powder or baking soda. So our chocolate cakes, our pound cakes, spice cakes, white cakes, yellow cakes. All right. Unshortened cakes made without fat. These are going to be the ones that are leavened with our beaten egg whites or our foam. So we're looking at the sponge cake. All right. We're looking at our angel food cake as well, where we literally take egg whites, turn it into a foam, and gently fold in our other ingredients. So chiffon, it's a hybrid of our shortened and unshortened cakes. These are leavened with both baking powder and with your beaten egg whites. So we have our chocolate chiffon or a lemon chiffon. Um, the cake that we're going to be making in class, it's our jelly roll. That is an example of the chiffon cake. So cake ingredients, just like our bread, they do have your basic flour, liquid ingredients, and a little bit of fat. But we're getting our sugar, milk, and our fat to flour proportions. They're going to be higher in our cakes than they are with our bread. We're also going to be focusing on cake flour because it has the low gluten potential to keep our final product nice and tender. Additional proteins, all right, we're going to get that from our flour and our eggs, all right. We need the proteins to contribute to the strength and the structure. And then, of course, we're going to be using fat and flour as our tenderizing agents. So sugar, again, it's a sweetener. It likes to steal liquid. It will increase the volume because it requires a higher temperature for gelatinization and coagulation, leaving for more steam. This does help with browning, all right, getting a nice color. We have the Maillard reaction, our protein, sugars, and our dry heat. And we're also going to be using caramelization. When we use the sugar, like as a finishing product with the dry heat, we will get that nice brown color on the top. Sugar also improves moistness and it binds with liquid. As a tenderizer, it competes for liquid, so it makes it less available for our gluten. But we do have to remember, take this into account. Too much sugar, the cake will collapse because it's going to give you a heavier product. And too little sugar, we're going to end up with something that's dry, tough, and crumbly. Our fats, all right, we have our plastic fats and we have our oils. Plastic fats, that's our cold fats. It's solid at room temperature. We have our butter and our shortening, such as our Crisco shortening. So we do cream the fats with the sugar to trap the air along with the sugar crystals. And our oils, we use these in commercial mixes and our tea breads to make things like our carrot cake. Fats are also known as a tenderizer because it makes the gluten and the gliadin less available by coating it. All right, when we're manipulating our product, too much fat will end up with something that's heavy and compact, and too little, something that's very dry and crumbly. So we want something that's got like good volume, got good moistness, and we all know where there's fat, there's flavor. So this is why we like using fat in our cakes and pastries. Eggs, we use them for our protein, all right? The egg whites. The proteins coagulate, meaning they go from a liquid form to something that's semi-solid. We also use the egg for its liquid, all right? That liquid plus the high temperatures creates steam, which acts as a leavener, all right? And then, of course, as an emulsifier. We have our phospholipid that we find in the egg yolk called lecithin. All right, that's going to help combine the fat and the lipid soluble and sorry, water soluble ingredients so that we get something that's nice and even. Eggs are also going to contribute to color and flavor and again, protein content. A lot of times we're going to be using milk as our main liquid, all right? Not all times, but a lot of times. This milk, being a liquid, is going to hydrate the dry ingredients, such as our starch and our protein. It's also going to help dissolve the sugar and salt. Milk also provides steam for leavening and provides liquid for our chemical reactions. So when we have our baking soda, baking powder plus acid, the liquid is going to help us produce some CO2, which is going to help with leavening. All right. So the leavening agents, all right, chemical leaveners, we have baking soda and or baking powder. All right. Again, we're going to do the chocolate cake experiment. The devil's food cake is a variation from the chocolate cake. We're looking at the color. All right. If we look over here, remember what we said about acids. Acids will bleach. All right. So we can tell by looking at this cake over here. This is our regular chocolate cake, and this is our dark mahogany colored devil's food cake. What the difference between the two is, this one over here has more acid. It's got a lower pH. Therefore, we're getting that rusty color here. Why? Because our chocolate cake, we use just baking powder. So baking powder, again, it's our baking soda with a little bit of acid and then some cornstarch. But the cornstarch is going to affect the pH. But this is going to be more acidic than this one. Why? We do use baking powder over here, which is the baking soda and the acid, but we're also adding extra baking soda. Baking soda is alkaline, so we neutralize it. We still get that CO2 action happening between the yeah, we get it from the reaction from the baking soda, the acid, and the liquid, but we neutralize the acid, all right, by adding more baking soda. So we keep it closer to 7 than this one, all right? This one will be lower than a 7 pH. We're also looking at liquid, and liquid is going to help aerate or leaven our cake by way of steam, and then, of course, air, all right? So this is a good example of our chocolates. All right. We're looking at the chocolate cake versus a devil's food cake. All right. Again, we're looking at the different pH levels. This is more acidic than this one. So therefore we get the bleaching. And we can see this here. The devil's food cake, all right, because we add the extra baking soda, is considered Dutched chocolate, all right? So we have this bright color over here, whereas your regular baking soda, sorry, baking powder with your chocolate, um, the pH is between 5.3 and 5.8. So again, we're going to get that bleach color as opposed to this one. This is very close to neutral, 6.8, and a little bit alkaline, 8.1. So that's why we get that darker color in the end. So we're going to make yellow cakes. So the yellow cake, we're going to be using the conventional method of mixing. So what we're going to do is we're going to cream the plastic fat with the sugar. All right. So literally taking the butter, all right, pouring the sugar in there, and you're going in with your hand mixer. Once you get everything mixed nice and evenly, maybe a little bit even aerated, we're going to add in our eggs. So this produces an emulsion with the lecithin and our fat. And this also contributes to the fine texture. So we add our sifted dry ingredients alternately with our liquid, and then we stir after each addition. This is going to give us something very tender and very fine. The single stage or the quick mix method, all right, we're using our devil's food cake for this one. It does have higher proportion of sugar and liquid, so we're going to sift our dry ingredients into a bowl, all the soft shortening and part of the liquid, all right? Once we get that nice and mixed together, we're going to add the eggs and the remaining liquid. This will give us something a little bit coarser, all right? We do we would like to, or we recommend to use our super glycerinated fats because it does have the extra emulsifiers in there. But we'll typically see this in your packaged cake mixes where you just add water. All right. Shortened cakes or cakes that have that are prepared with flour, sorry, prepared with fat. When we're putting our pans together, all right, you want to make sure you grease and you dust the inside of the pan with flour. All right. You want to make sure you also get rid of any of the excess flour. What this is going to do is it's going to allow it to release a lot quicker. All right. A lot easier. And then we can just flip it upside down and take it out of the pan after you cook it. So when you're working with your shortened cakes, we're going to preheat the oven to around 325 to 350. Um, and we're going to cook these for about half an hour or a little bit more than that, half an hour to 45 minutes. When you're placing it into the oven, you want to make sure you put it on the middle rack to allow for air circulation. And when testing for doneness, you can look at it. Does it shrink a little bit? It will shrink because it is getting rid of a little bit of that moisture, that liquid. You want to use a toothpick, all right? When you poke it with a toothpick, you want to make sure that it comes out dry. You don't have any like wet cake batter there. You can also test it with your finger. So if you press on the middle, the center part, because the center is the last place that will end up cooking. If it bounces back to the touch, or if you see some wrinkles because it is shrinking or cooks away from the pan, you know you're good to go. So during baking, the volume will increase because you are adding air, you have the steam in there. You also making sure that the protein coagulates. All right, the protein, we have our gluten and we have our egg, and you want to make sure that the starch does gelatinize. Remember, we're looking at starch plus liquid plus heat. All right. The fat will melt away. That's going to give you something either tender or flaky and tender, and you're looking for the Maillard reaction to happen. So you'll know that happens when your crust browns. As far as cooling, you want to cool it on a rack. Again, for optimal air circulation and to prevent sogginess. Remember what's going to happen. The starches and the proteins are going to start letting go of water. It's going to be sitting in its own water. So you want to make sure it's cool from the top and the bottom. Our angel food cake, that's an example of your true foam cake. All right, we're going to be using cake flour for this because of its low gluten potential. We're also going to be incorporating egg white foam. All right, the egg whites, you want to beat them to stiff peaks. Um, your eggs and your equipment, you want to make sure that it's room temperature so we can get optimal height from our foam. When you're folding in the flour, you want to do it in three parts. You don't want to do it all at the same time. What happens is if you put it all at the same time, the weight of the flour is going to crush the foam that you just created. It's going to give you something that's very, very dense. We will be using cream of tartar. Our cream of tartar, we're going to be putting that into our egg white foam at the foamy stage. All right. It stabilizes the foam and it also helps with softening that protein. So the protein from the egg whites, it helps produce a whiter cake. It helps produce because of the acid. It also helps produce a stiffer foam or higher foam. And the sugar, you want to be careful with this. You want to add half to the foam at the soft peak stage because, again, sugar will weigh it down and create something that's very heavy and dense. Our sponge cake, it is similar to the angel food cake, but there's no added shortening, meaning we're not adding any fat to it. However, we are adding fat indirectly. All right. We're not adding butter. We're not adding oil. We're adding the fat from the egg yolk. All right. So what you want to do is beat the egg white foam and the egg yolk separately, and then we will mix that, taking advantage of the foam that we created. Your jelly roll, all right, that's a chiffon cake. It's not a true foam because we do add a little bit of fat to it. All right. And it is leavened by a small amount of baking powder. So it's got a combination of the two. When you're working with your foam cakes, all right, you want to make sure not to grease this pan. This is the pan that you're going to be using for the angel food cake. Why do we use this? It's got a very gritty inner lining on the inside. You want to pour your batter into this, all right, on the bottom portion of the pan. You are going to line that with a little bit of paper, but the sides are going to be ungreased and they're going to be unpapered. All right. Why do we do this? When the cake is cooking in the oven, we're looking for that initial oven spring. We want the cake to have something to hold onto. All right. So the higher it gets, the stickier it gets. It'll hold on to the outer lining of that cake pan, so it gets higher. When you're taking it out, all right, we are cooking the pan, the angel food cake upside down. When you take it out, you want to make sure you cool it upside down like this. What this is going to do is because we have that big temperature difference between the oven and the room temperature, you don't want it to shrink. Putting it upside down would use its own weight to stretch out those gluten strands so it remains nice and high. So after it's cooled completely, all right, it's cooled inverted or upside down. After it's completely done cooling, you go in there with a knife and then you flip it upside down again and you have something that's nice and high. All right, this is your bundt pan. All right. Unshortened cakes, you want to make sure that you preheat the oven to 350 or 375, and it goes for 45 minutes to an hour. When you're testing to see if it's done, you're looking for a slightly brown surface, and you want to make sure that it does spring back to touch. You can also use a cake tester. I've had people use shish kebab skewers. You can use a piece of spaghetti. You can use a toothpick. You just want to make sure it comes out clean. This over here is your angel food cake. Remember, we cooled it upside down. We flipped it back over. This over here, the angel food cake, it doesn't have any fat to it, but it is very, very, very sticky. It's also very susceptible to crushing. It's very light. Remember, we cooked this with a foam. So you're going to use one of these forks. All right, you stick it into the angel food cake and you shake it back and forth until you get a cut. All right. If you use a knife, the knife will collapse it. But we want to look at the manipulation. All right. We remember we're using the egg white foam and we're also incorporating the flour into it. You want to mix it so that it doesn't come out too uneven. You also you want to make sure you don't mix it too much that it comes out completely you want to hold on to or preserve that foam structure. If you beat it down or if you mix it too vigorously, you can break down that foam and you'll get something that's very compact, very dense. This is what the optimal folding will result in. All right. You're not getting the tunnels, you're not getting dense, you're getting something nice and light. But remember, it is very sticky. When you're storing your cakes, they do tend to stale very quickly, so you want to keep them covered. Remember, staling just means it's losing liquid. To extend the shelf life, all right, we're going to use the same concept as your, what is it called? Your crisper drawer in the refrigerator. You're going to stick half a, an apple that's cut in half into the cake box, and you're going to close the cake box. Remember, water likes to find equilibrium. A cut apple does release water. So you're going to have the cake that dries out, all right? And it's going to send water into the cake box. It's not going to be able to leave. And then it's just going to keep on going back and forth. That apple is going to act as a humidifier for the cake box. All right. So it keeps the humidity levels at like an optimal level so that it doesn't dry out, and this will keep it nice and moist for a longer period of time. When you're frosting your cakes, you want to make sure that they are completely cooled before you add frosting. Why? This is going to add, it will melt your frosting, all right? So you're going to have less moisture loss. You're going to make sure that the cake doesn't like fall apart on you. So frost your cakes after they are cooled 100%. And if you want to, you can freeze your cakes, all right? To bring them back to room temperature or thaw them out, you just keep them on the counter. You don't have to put them in the refrigerator. So your basic pastries, all right? We've got different types of dough, all right? So your dough does contain moderate to a large amount of fat. Think of croissants, all right? So this mix is to promote flakiness. We're using high amounts of fat. We're using plastic fats or cold or solid at room temperature fats to get us something that's nice and flaky. All right. Why does this happen? Because the fat literally creates a barrier between gelatinized starches, and when you put them into the oven to cook, it melts away after the starch has gelatinized. So when you're making a plain pastry, all right, the basic ingredients, we have our flour. We can use pastry flour, cake flour. We can use AP flour, but most of the time we're going to be working with pastry flour, very low gluten potential. We're also going to be working with a lot of fat. So solid shortening, all right. We have our lard, we have butter. That's going to give you a flaky dough. Liquid shortening, it does the same thing, but it doesn't melt away like your plastic or solid shortening does. So it'll give you a tender product, but it's not going to be flaky. You also want to make sure you mix them properly, all right? So you don't want to overwork your dough. You don't want to overmix it. You want to make sure that you mix it just correctly because through manipulation, you can create too much gluten, but you want, again, something that's not too not too tough. When we're making pie dough, you want to overwork that one because you want it to hold on to your other ingredients, your wet ingredients or your pie fillings, all right, which do tend to be very high in moisture. So the pastry method of mixing, all right, we have our pastry blender over here. This guy with the little spikes on, little blades on it. You want to cut the cold fat into the flour, all right? You can cut the flour before, sorry, you can cut the butter beforehand in small pieces, but when it says cutting the fat into the flour, you're basically just taking the fat and you're like mixing it in until it looks like cornmeal or sand. You want to gradually add your cold liquid and mix as little as possible, and then you flatten your dough onto a floured surface and roll it out. When you're making your pie shells, if the pie shell is filled before baking, you want to make sure that the you put the filling in the crust and you bake it immediately. Why do you want to do this? Because if you put the pie filling in too early and let it sit, it will break on the bottom. You'll end up with a soggy pie. You also want to flute the edges over here. You see what she's doing over here with her fingers? What basically this process is to prevent shrinkage, all right? When it goes into the oven, the liquid is going to come out, the fat is going to melt, the pie crust is going to get a little bit smaller. This basically anchors it to the side of the pie dish. If the pie shell is baked before filling it, all right, you want to make sure you dock the shell. All right. So you take a fork and you put little holes in the pie crust bottom before you put it into the oven. You flute the edges. You cook this off. What this is going to do is going to any liquid or steam that gets created once you go into the oven, it's giving it a way to escape. If you don't do this, you're going to end up with bubbles underneath on the bottom of your pie crust, and it's going to be uneven. So this allows it to cook flat. We also have the blind bake method. Instead of doing your perforating the bottom, what you can do is you can put your pie crust into the shell. Sorry, you can put your pie crust into the baking dish. You perforate it, all right, and then you can weigh it down to prevent bubbles on the bottom of the thing. You can weigh it down with pie weights or dry beans. The pie weights are usually just small um, clay balls, all right? They don't have a lot of flavor. You can reuse them and you can bake it until light brown and then you can have it. This is a way to prepare it ahead of time so you can fill it and bake it as needed. Your puff pastry, all right? Our puff pastry, it's a rich dough, so it has butter or fat in there. It separates into many light crisps. If you've ever had like spanakopita or what is this over here? The Neapolitan cake. It is leavened by steam. The phyllo dough, it doesn't have the flavor of the fat in there. You just get very thin sheets of just flour and liquid. You separate them on your own. You can go in there with butter. You can go in there with oil. So you get that like separation there. Very bland in flavor. All right. Gelatin. We're almost there. So gelatin is a protein, all right? This is formed from the hydrolysis of collagen. Where do we get collagen? We get collagen from the bones. We have collagen from it is a protein in animal um, that comes from animal sources. All right. So it's found in connective tissue. The primary source of gelatin that we use in the United States comes from cows, pig, and fish. All right. It's the tissue, it's treated to separate the collagen. Basically, if you're making a stock, you're cooking bones down. If it turns into a gelatin, that gelatin is the collagen that we use, right? We use it for thickening, we use it for candies, we use it for a multitude of different purposes. But we do purify it, all right? We convert it into the gelatin and we recover it in a dry form. We do have vegan or vegetable-based gelatins. All right, so these are made from your dietary fibers. We're looking at agar-agar, natural gum, carrageenan, and pectin. Pectin, we spoke about it several times. We find it in our apples. Carrageenan is found from seaweed. These have no chemical relationship to gelatin. So if you're serving someone that is kosher or vegan, vegetarian, this is a good option. All right. So how do we use gelatin? We use it to form the basic gel structure. All right. You guys will be making the whipped green pie in the lab. This is a delicious pie. It does melt rather quickly. You are going to be using condensed milk as a foam. You're also going to be adding lime jello to this. It looks weird. It sounds a little bit funky, but it is quite delicious. Gelatin, we also use it as a thickener in some puddings, but we also use it to control the crystal size in candies so that it stays nice and clear. If you have very large crystals in your candy, it will have like a opaque look to it. You won't be able to see through it. So gel formation happens in three phases. All right. We spoke about this several times. The gel, number one, the first thing you want to do is hydrate it in cool water. All right. So once you hydrate it or you let it bloom, you add the hot water to it at around 100 degrees. And what it does is it denatures or unfolds that protein. Once the protein unfolds, all right, it starts aggregating with other proteins, and then it's trying to, as it gets cool again, it tries to go back to its natural shape. Because you denatured it or you opened up the protein and um, you soaked it in some sort of liquid, whatever flavor you want to add to it. As the protein starts to close up again, the water or the liquid gets trapped there. All right. So as it starts to cool, it's going to try its hardest to get back to its natural shape, but it will close with the water trapped inside. And this is how we end up with a gel. All right. So it's just locked in. It's not permanent. It will melt if you, because we didn't coagulate it, we only denatured it and let it close up on its own. Um, this can go back to its natural shape. So if left at warm temperatures, it will start releasing liquid. All right. So to maximize your gelation process, all right, if you're using unflavored gelatin, you want to hydrate it in cold liquid and then add your boiling water. Because we added dry ingredients to your flavored gelatin, you can do hot water directly into the mixture. All right. Why does this work? Why is it not going to clump? Because we separated it by dry ingredients. Gelatin is a protein, all right? So we can, there are enzymes out there that will break down the protein, all right? So this prevents your formation. So if you're using fresh pineapple, all right, the enzyme that we find in pineapple is bromelain, all right? If you've ever had pineapple and you start feeling the little tingliness on your tongue, that's the enzyme found in the pineapple, the enzyme that's actually attacking the protein in your tongue. We also have papain from your papaya, and phycin has fresh, you'll find that in your fresh figs. Again, gelatin is a protein, all right? It's made from collagen. So if we're putting fresh pineapple into our gel mix, if we want to do like a fruit jello cake or whatever we want to do, it's going to prevent the gelation process. Okay, so it's going to break down the proteins and it will irreversibly denature the proteins. All right, so you want to be careful with that. You guys will have an experiment there. If you're working with gelatin and you want to make it gel quicker, all right, or you want to speed up the process, you can speed it up by adding ice. And it will melt more readily. All right, so the gel does melt readily. If you want to make Jello jigglers or a firmer gel, you can do that by simply adding extra amounts of gelatin. You can do like a water to or a liquid to gelatin ratio. You can play with those ratios to get something a little firmer, a little something a little bit softer. If you're working with acid, all right, that'll give you something like a softer gel. All right, this is good for different types of cakes. And if you want to add like different fruits to it, you can wait till the gel sets 50% of the way. You can mechanically break the gel and add whatever you want in there. But you want to be careful. This is nice. It keeps everything dispersed instead of everything falling towards the bottom. So different types of products that we have made with gelatin. We have our gummy bears. We have sour cream has gelatin incorporated into it. Cream cheese, our marshmallows, some soups and gravies, commercially produced soups, sauces, and gravies do contain gelatin. And of course, our canned ham, canned chicken, corned beef, and sausage because it is naturally occurring in the meat products. So that's it for our lecture. I hope you have a great time in lab. I'm sure you guys are going to cook things that are very, very delicious. Um, when we meet up again, not this Thursday, not this Wednesday, the following Wednesday, we are going to go over the review sheet. Your exam is postponed 1 week because I do want to make sure we do a really good review. And that's it. That's all I have for this week. Have a great time in lab, and I'll see you when I get back. Have a good one, everyone.